All right, problem number 9 here is a slightly more difficult version of problem number 8. In problem 8, we gave you the empirical formula. Here we're going to make you do work for the empirical formula and then find the molecular formula. So start with our table here to find our empirical formula. The elements in the compound are carbon, hydrogen, and chlorine. Okay, just like we did in problem number 6, if we pretend like this is a 100-gram sample, then these percentages become masses, 46.47, now grams, 7.80, now grams, and 45.72 grams. Okay, from there, I'll need my molar mass for my periodic table. For carbon, that's 12.01. For hydrogen, that's 1.008. And then for chlorine, it's 35.45. So I have my mass, I have my molar mass. If I divide my mass by my molar mass, I can figure out the number of moles of each one of these. Number of moles that would be present in 100 grams of the compound. Okay, so 46.47 divided by 12.01, 3.869, 7.80 divided by 1.008, 7.738, and 45.72 divided by 35.45, 1.2889. All right, well, now let's divide all of those by the smallest number to get our ratio. So the smallest number is the 1.289. So it divided by itself is 1. 3.869 divided by 1.289 is 3. And 7.738 divided by 1.289 is 6. So our empirical formula here is C3H6Cl. Let's go ahead, and we've got our molar masses here, so this should be easy. We need the mass of our empirical formula. So 3 times 12.01 plus 6 times 1.008 plus 1 times 35.45 equals. Okay, my mass of my empirical formula is 77.53. And so I'll remind you again, X times the mass of the empirical formula is equal to the mass of the molecular formula. X times 77.53 is equal to then 155.06, and so X is 155.06 divided by 77.53. Okay, or exactly 2. And so my empirical formula, just rewrite it over here, is C3H6Cl. And my molecular formula is twice as massive, so I need to double all of these. C6H12Cl2.